Footprinting concept. Footprinting is the first phase of any ethical hacker or penetration testing engagement. It's like a scout meticulously mapping out enemy territory before a mission, gathering every possible piece of public information about a target organization. The primary goal of footprinting is to collect data that can be used to identify vulnerabilities, develop attack vectors, and build a comprehensive profile of the target's security posture. This can involve passive information gathering, where you don't directly interact with the target, or active method that might involve some level of direct engagement. Key information sought includes network ranges, domain names, employee details, public-facing applications, and even financial data. Think of it as putting together a puzzle where each piece, no matter how small, contributes to the overall picture. For defenders, understanding footprinting helps them identify what information is publicly available about their own organization, allowing them to better secure it. Footprinting through search engines like Google, Bing, or DuckDuckGo are incredibly powerful tools for gathering open source intelligence. It's like having an enormous public library at your fingertips where you can find documents, forgetting web pages, or even misconfigured servers by simply knowing the right keywords. Attackers use specific search queries known as Google Docs to unearth sensitive information that organization might inadvertently expose. This can include confidential documents, employee directories, login portals, or even error messages that reveal underlying system details. The process involves combining operators like site file type in URL or in title with keywords to narrow down searches and pinpoint relevant data. For example, you might search for a specific document type within a target domain, revealing internal reports or old policies. This technique is effective because many organizations overlook the vast amount of data indexed by search engines. Now, practically, let's see how Google Docs can reveal hidden files. We will use Google Search Bar, a widely accessible web-based tool, to do this. We type a specific site, example.com, file type, PDF confidential. This instructs Google to search only within example.com for PDF files containing the word confidential. The result, we see several PDF documents such as confidential reports or Project Omega docs directly exposing search results. This step is crucial. It shows how easily sensitive internal documents can be discovered. Attackers can leverage this to gain valuable insights without ever directly interacting with the target servers. Footprinting through social networking sites like LinkedIn, Facebook, and X, formerly Twitter, are treasure troves of information for footprinting. It's like observing people in a busy public square where their conversations and shared details can inadvertently reveal critical information about their organization. Attackers leverage these platforms to gather details about employees, organizational structure, internal projects, technologies used, and even personal habits that could be exploited through social engineering. For instance, an employee's public resume or LinkedIn might list specific software skills, giving an attacker clues about the company's tech stack. This process involves searching for employees, identifying their roles, understanding reporting structures, and looking for any shared post or discussion that might inadvertently leak sensitive operational details. Now, practically, let's see how LinkedIn can provide organizational details. We will use LinkedIn, a popular web-based professional networking site, to do this. We navigate to the search bar and type company example corp. Employee then filter by people. This instructs LinkedIn to show us profiles of individuals who work at example corp. The result, we see a list of employees from example corp, including their names, titles like senior developer, HR manager, and network engineer. This step is crucial. It reveals employee names, their roles, and even connections, which can be used to map out the organizational hierarchy or identify potential targets for phishing and social engineering attacks. Website footprinting. Website footprinting involves methodically analyzing a target's website to gather intelligence. It's like carefully examining every room and blueprint of a building to understand its structure, security measures, and hidden passages. Attackers scrutinize every element of a website, from its source code and directory structure to its error messages and meta information. This can reveal server types, content management systems, programming languages, hidden directories, outdated bloggings, and even developer comments that might expose vulnerability. Techniques include analyzing the robot's text, file for disallowed directories, examining HTML comments for sensitive data, identifying technologies through browser extensions, and checking for common vulnerability. Now, practically, let's see how we can mirror a website for offline analysis. We will use httracks, a versatile tool available both as a command line and GUI applications to do this. We hitrack paths to save. This command instructs httrack to download the entire example.com website to a specific local directory for offline analysis. This result, httrack confirms its mirroring and has saved the content, indicating the number of files and images copied. This step is crucial. It allows attackers to analyze the website thoroughly without directly interacting with the live server, reducing their digital footprint. They can comb through every page, script, and image at their leisure to uncover hidden directories, forgotten files, or vulnerable configurations. Email, email footprinting. Email footprinting involves analyzing email headers and patterns to extract valuable information about a target. It's like being a detective examining a letter envelope and postmark to learn about its origin, journey, and sender, even before reading the contents. Attackers examine email headers to identify the sender's IP address, mail servers, sending software, and even time zones. This can reveal the underlying network infrastructure, email service providers, or geographic location of the sender. It can also help identify valid email addresses within an organization, crucial for phishing campaigns. Techniques include sending a binning email to the target and analyzing the bounced message or header of a received email using online header analysis tools or even leveraging email validation services. Publicly available email addresses from websites or social media are also collected. Now, practically, let's analyze an email header to gather intelligence. We will use an online email header analyzer, a common web-based tool, to do this. We paste the raw full email headers into the analyzer input field. This tool then passes the complex header information into a readable format. The result, the analysis reveals key details such as the sender's IP address, the email server that sent the email, and possibly intermediate servers it passed through. This step is crucial. It provides attackers with network infrastructure details, potentially revealing the target's internal mail servers or the specific IP ranges associated with their email communications. Hoist footprinting. Hoist footprinting involves querying public databases to retrieve registration details about domain names and IP addresses. It's like looking up a property deed at a public record office to find out who owns it, their contact information, and when they acquired it. Attackers use Hoist data to uncover critical information, such as the domain owner's name, organization, contacts, email addresses, phone numbers, physical addresses, domain registration and expiration dates, and the associated DNS name servers. even if some information is privatized. The registrar details and creation dates can still be valuable. The process typically involves using a host client or a web-based host lookup tool. You simply enter a domain name or IP address, and the tool queries the relevant host database to retrieve the public registration record. This method is highly effective because host databases are a standardized way to ensure accountability on the internet. We will use the host command line tool, which is commonly available on Linux systems, or a web-based host lookup service. To do this, we type whoisexample.com. This command queries the whois database for information related to the example.com. The results we see details such as the domain name, registrar, registrant name. Even if privatized, the city and country might be visible, and crucial dates like the creation and expiration dates of the domain. This step is crucial. It provides attackers with the administrative and technical contact information, which can be leveraged for social engineering or to identify potential targets. It also reveals the domain's age, which can indicate its stability, and the name servers, which point to the domain DNS. DNS footprinting. DNS footprinting involves querying domain name system records to map an organization's network infrastructure. It's like consulting a phone book for the internet, where you can find out the phone numbers, IP addresses for various businesses, domains and subdomains, and even their different departments. Attackers leverage DNS to discover host names, IP addresses, mail exchange servers, and potential internal network naming conventions. Key record types include records for the IP addresses, MX record for mail servers, NS records for name servers, and SRV records for service location. Identifying subdomains can also reveal hidden applications or test environments. Techniques range from simple lookups using tools like NSLOOKUP or DIG to attempting zone transfers, which, if successful, can provide a complete list of all host names and IP addresses within a domain. Now, practically, let's perform a DNS lookup for a target domain. We will use NSLOOKUP, a command line utility available on most operating systems. To do this, we simply type nslookup.example.com. This command queries our configured DNS servers for the IP addresses associated with example.com. The result, we see the DNS server that provided the answer, and crucially the IP address 931.842.1634 associated with example.com. This step is crucial. It provides attackers with the IP addresses of the target public web server, which is the first step in identifying entry points. Further, queries can uncover mail servers, subdomains, and other network resources, building comprehensive map of the target's online presence. Network footprinting. Network footprinting involves mapping out the target's network infrastructure, identifying live hosts, open ports, and device types. It's like a reconnaissance team surveying an area to understand its layout, access points, and defensive perimeters. Attackers aim to discover the target's IP address range, subnet allocations, network topology, and the presence of firewalls, routers, and other network devices. This helps them understand the target's network boundaries and potential points of entry. Techniques include using traceroute to map the path to a host, which reveals intermediate routers and gateways. Port scanning tools are also used to identify open service on hosts, providing clues about their function and potential vulnerabilities. Additionally, network scanning tools can detect live hosts within a specific IP range. Now, practically, let's trace the route to a target domain to understand its network path. We will use traceroute, a command line utility available on most operating systems. To do this, we type traceroute.example.com. This command sends packets to example.com and record the paths they take, showing each router or hop along the way. The result, we see a list of IP addresses and host names representing the routers that the packets traverse, which can expose the target network architecture and potentially identify specific network devices, their location, or even service providers. Attackers can gain insight into firewall placement and network segmentation. Footprinting through social engineering. Footprinting through social engineering involves manipulating individuals into revealing information, often without them realizing they have done so. It's like a skilled interrogator gently extracting details from someone by building rapport and exploiting human tendencies rather than resorting to force. Attackers might impersonate trusted individuals, such as technical support, new employees, or vendors to gather network diagrams, credentials, or organizational policies. This can occur through phone calls, emails, or even face to face interactions. The goal is to exploit human physiology, trust, helpfulness, curiosity, or fear to gain access to information that wouldn't be publicly available. Techniques include pretexting, where an attacker creates a fabricated scenario to engage with the target, phishing using deceptive emails to trick individuals, and baiting, where a malicious device is left for an unsuspecting victim to discover and use. The information gathered might seem insignificant on its own, but it can provide crucial pieces to an attacker's puzzles. This method is incredibly effective. Footprinting tools automate information gathering, acting as high-tech detective kits. They range from simple command line utilities like NSLOOKUP to advanced graphical applications such as Multigo, streamlining the collection and analysis of public data. Some tools focus on network intelligence, others on open source intelligence from social media or public records. Efficient tool usage save time, enabling rapid target profiling for attackers and informing defensive strategies for organizations. Now, practically, let's see how a powerful OSINT tool can consolidate footprinting data. We will use Multigo, a graphical link analysis tool for open source intelligence. We start a new graph, add a domain entity, for example.com, and run transforms like to company, to person, and to DNS name. Multigo then queries public sources and visually draws connection. The result, we see example.com linked to its DNS servers, IP addresses, identified individuals, and related companies in a clear graphical representation. This visually maps relationships. Footprinting countermeasures. Footprinting countermeasures are the defensive strategies organizations implement to minimize their public exposed information, thereby reducing the attacker's ability to gather intelligence. It's like a spy agency employing strict protocols to control information leaks and prevent adversaries from building a profile of their operations. The goal is to limit the attack surface by controlling what information is accessible through public channels. This includes scrutinizing websites' content, social media profiles, and public records to ensure sensitive data is not inadvertently exposed. Key strategies involves using privacy services for domain registration to hide personal details in HOI records, implementing strict access on public-facing servers, and ensuring that robots.txt properly disallows indexing of sensitive directories by search engines. Organizations also need to educate employees on what not to share on social media. Regular audit of an organization's digital footprint are essential to identify and remediate information leaks. For instance, checking Google Docs regular for your own domain can reveal hidden files. It's about making the attacker's job harder right from the start.